Legacy PHP applications often follow a predictable and dangerous pattern. UI rendering, SQL database queries, and core business rules all end up woven into the exact same procedural files. When you attempt to run a massive batch load through this kind of tightly bound system, the logic chokes and the application crumbles. To solve this, the XOOPS 4 ecosystem adopts domain-driven design. We separate the mechanics of the website from the actual vocabulary of the business. The architecture divides into 3 distinct isolated layers. At the base is XMF, providing the physical infrastructure and database tools. In the middle sits XBO, the business domain layer containing all the actual logic. And on top is XTF, handling the presentation and user interface. The flow of dependencies between these layers travels in one direction, strictly upward. The business domain never relies on the user interface, and the interface never dictates the business rules. By enforcing this structural isolation, we scale complex business logic without ever corrupting the database or the presentation layers. Zooming in, XBO operates entirely as a pure PHP environment. It models business facts, like an invoice or payroll slip, strictly in memory. It operates with absolute amnesia. An XBO object contains 0 database connection logic and 0 HTML rendering instructions. This complete detachment protects your core logic. If browser rendering technologies change, or if the database schema needs migrating, the business rules remain entirely untouched. Because the domain is ignorant of how it is invoked, the exact same business rules execute identically, whether initiated by a user clicking a button in the admin panel or by an automated headless cron tab running at midnight. Severing the business domain from the infrastructure guarantees that the enterprise brain is never contaminated by the presentation shell. Data corruption is blocked at the perimeter using value objects. These are immutable gatekeepers that ensure logically invalid data never enters the system to begin with. Take the money object. XBO strictly bans floating point math to prevent rounding errors, storing all amounts as exact integer minor units. If you try to mix incompatible currencies, like ringgit and US dollars, the action is physically repelled at the type level. Older architectures relied on repetitive procedural checks scattered randomly across dozens of controller files, hoping a developer didn't forget one. Here, the constraint is baked directly into the type definition. If an XBO value object successfully instantiates in memory, it is already valid. You permanently eliminate entire classes of runtime surprises before the code even compiles. To map ambiguous requirements into these precise PHP classes, XBO uses a specific design language known as modeling and color. We classify concepts into 4 archetypes. Pink represents a moment interval, the central business event tracked over time, like an invoice. We add governing elements: yellow for participating parties, like a customer, green for roles, like an approver, and blue for rules, like a tax policy. When you strip away the technical jargon, the resulting domain graph reads logically. A yellow customer plays a green role to execute a pink event, governed by a blue rule. This provides developers and domain experts with a shared, unambiguous vocabulary. You can architect and verify the entire system conceptually before writing a single line of logic. The true test of this architecture occurs under heavy load. For example, importing a batch of 10,000 invoices from an external API. A traditional procedural loop addresses this by saving one row at a time. If record number 5000 fails validation, the batch is already half committed, with no clean way to roll back. The script runs out of memory or simply locks up the database. The XBO application layer approaches this differently. Without needing a database connection, it instantiates all 10,000 records in pure memory. Every rule is validated in isolation. Only after every object passes inspection does it write the batch to infrastructure in one clean operation. During this process, expected business violations, like an invoice carrying a negative total, do not throw fatal system exceptions. Instead, they are returned as structured data packets called results. We reserve exceptions strictly for physical infrastructure fires, like losing server power. The application layer functions as an impenetrable orchestration boundary. Only flawless, fully validated data survives to reach persistence. When a significant business state changes, entities make formal announcements called domain events. Broadcasting an event immediately is dangerous. If you trigger an email saying an invoice was approved, but the database transaction subsequently fails and rolls back, your system has lied to the user. To prevent this, XBO enforces a strict collect-then-dispatch rule. As operations occur, the entity holds its own events captive internally. Those events are only released into the routing bus after the infrastructure layer definitively confirms that the database write was successful. This structural guarantee means you never have to worry about out-of-sync module reactions. Downstream systems only ever respond to immutable, permanent facts. We see the engine in motion when a payload strikes the application boundary. The data instantly materializes into designated business shapes. Validated by value objects, the records commit safely downward to the persistence layer, while events simultaneously dispatch upward to update the presentation UI. By decoupling the logic from the mechanics, the framework scales from a basic procedural content manager into a resilient, enterprise-grade business application platform. Model the business in XBO, build the module with XMF, and make it